Hello guys, you're welcome. It's Dr. Cliff. Today we are going to talk about oxidation number calculations. Okay, uh, right on the board I have three different compounds. Okay, three different compounds, and in this compound we are going to determine the oxidation state of phosphorus. In this compound, we're going to determine the oxidation number of chlorine. In this compound, we're going to determine the oxidation number of what? In this compound. Okay, so oxidation number of phosphorus in this compound, oxidation number of chlorine in this compound, oxidation number of phosphorus in this compound. So that's what we are going to calculate for. All right. Now, these are all neutral compounds. Okay. Now, when you have, the very first thing we do is to say Ca3PO4 2 equals to 0. I will do the same for this. CaClO3 equals to 0. I will do the same thing for this. Why am I doing this? Because they are all neutral compounds. Okay, they are all neutral compounds. Now, if it was, let's say we had NO3 minus, will I have equated to 0? No, I would have. This can be done. I will equate to -1 because this is a charged species. Okay, if I have SO4 2 minus, I cannot equate to 0. Right? Instead, I will equate to -2. If I have PO4 3 minus, I will equate to what? -3. You get that? Why? I am equating to the net charge. The net charge here is -1. The net charge here is what? -2. The net charge here is what? -3. So that's why I equate to. But for this, the net charge, come on, is 0. There's no charge. Okay, that's why I'm equating to 0. Okay, you get the concept now. That's the very first thing you must know. All right. So having known that, the next thing we need to know is for compounds that have parentheses. This has parentheses. You can see the parentheses. For compounds that have parentheses, what do? We usually remove it. We usually open up the parentheses by multiplying with the value outside it, outside the parentheses. Okay, so we multiply. This is what I mean. If we do that, we'll be having Ca3. So 2 times P, that will give us P2. 2 times O4, that gives us what? O8 equals to 0. So this is what we do. Okay, so this is what we do. We do this in order to avoid confusion. So if I come here now, I will be having Ca, so 2 times chlorine, that will be Cl2, 2 times O3, that will give us what? 2 times 3, that's 6, O6 equals to 0. I will do the same thing here, Ba, so 2 times H2, that will give us what? H4, 2 times P, that will give us P2, 2 times O2, that gives us what? O4 equals to 0. We are doing this in order to avoid ambiguity, in order to avoid confusion. Okay, so doing it like so, it becomes pretty easy for us to solve. Okay, now in this compound we are calculating for phosphorus. Now, how do I know the oxidation number of these components? Okay, how do I know? I'm going to sum up the oxidation number to determine this, isn't it? Now, how do I know the oxidation number? Now, easy trick. Calcium is in group 2. Now, elements in group 1. Elements in group 1 such as lithium, sodium, potassium. Okay? The oxidation number is usually what? +1, +1, +1. Elements in group 1. Elements in group 2, like magnesium, calcium, even barium. I can see barium there. All of them are what? All of them have oxidation number of +2, +2, +2. Okay? Elements in group 3 like aluminium. Aluminium is in group 3. Aluminium will have a charge of +3. So when you see aluminium, know that the oxidation number of aluminium is +3. When you see any group 2 element like magnesium, calcium, barium, they have oxidation number of +2. When you see group 1 elements like lithium, sodium, potassium, the oxidation number is what? +1. Okay. Now, you know that now, isn't it? Now, what about oxygen? Oxygen usually have oxidation number of what? -2. Okay. Except in peroxide. Except in peroxide, where it has oxidation number of what? Except in peroxide, where it has oxidation number of what? -1. Okay. Except in peroxide, where it has oxidation number of what? -1. For example, in hydrogen peroxide, oxygen does this is hydrogen peroxide. So this is not an oxide, this is a peroxide. So in hydrogen peroxide, oxygen is going to be having oxidation number of what? -1. In superoxide, oxygen will be having oxidation number of what? -half. Okay. So that is all you need to know. Now it becomes easy to solve now. Okay. So here I will say calcium is +2. So instead of writing +2, I can write it as 2. It's the same thing. 2 times 3, because I have 3 of calcium, plus phosphorus, P2. So I will write it as 2P. Instead of saying P2, I'll write it as 2P. Okay, it's the same thing. Plus oxygen is -2 times 8 equals to 0. Okay. Now what next? 2 times 3 is 6, plus 2P, plus -2 times 8 is what? That's minus what? 16 equals to 0. Now 6 plus 2P plus minus is minus, -16 equals to 0. Now 6 minus 16, that's -10, plus 2P equals to 0. Now -10 will cross the sign of equality to this side to become what? +10. Okay, because we are looking for P. So it becomes 2P, because we want P to stand alone, right? So 2P becomes 0 plus 10. Okay, 0 plus 10. And you know that 0 plus any value is that same value. So 0 plus 10 is what? +10. So we're going to divide both sides by 2. When we do that, P becomes what? Therefore, P becomes what? +5. Okay, so the oxidation state of phosphorus in this compound is what? Is +5. So this is what? Calcium phosphate. So the oxidation state of phosphorus in calcium phosphate is +5. So this is going to be called calcium tetraoxophosphate 5. Okay, so the oxidation number or oxidation state of phosphorus in this compound, calcium phosphate, is +5. Now let's go to this. Now we understand it to this extent now, right? Just follow the rules. Okay. Now calcium, I'm looking for the oxidation state of chlorine, right? Chlorine. Now calcium is +2. We've already established that. 2 plus, let's sum up. 2 plus chlorine. Instead of saying Cl2, I'll write 2Cl, 2 chlorine. So you see the same thing as 2 chlorine. Okay. -2 times 6. Oxidation number of oxygen is -2. So equals to 0. So I'll sum up now. 2 plus 2Cl -2 times 6 is what? That's -12. So 2 plus 2Cl plus minus is minus, -12. Okay. So 2 minus 12. Okay. Just like, taking the like terms. So 2 minus 12 is what? Minus, come on. That will give us -10 plus 2Cl equals to 0. So -10 will cross this sign of equality to this side to become what? +10. So that 2Cl can stand alone. So 2Cl becomes what? 0 plus 10. Okay. So we're going to divide both sides by 2 so that we can have chlorine standing alone. Okay. So when we do that, chlorine becomes what? Chlorine, 2 we cancel 2. So, okay. So I think I should be systematic. So -10 will cross the sign of equality to this side to become what? +10, right? So that will give us 2Cl equals to 0 plus 10. Okay. So you get that now because we are looking for chlorine. We want chlorine to stand alone, right? Isn't it? So you see 2 chlorine is equals to 0 plus 10 is still the same thing as +10, right? So because we want chlorine, we are looking for chlorine atom 1 chlorine, we just want to determine the oxidation number of chlorine, not 2 chlorine. We're going to divide both sides by 2. So chlorine becomes what? We'll divide both sides by 2. So this, we cancel this, okay? So such that 10 over 2 will give us what? Plus 5. So the oxidation number of what? Chlorine in this compound is what? Is plus 5. So this is calcium trioxochloride 5, or calcium chlorate. So the oxidation number of chlorine in calcium chlorate is plus 5. So let's come to this. So for this is what we have. We follow the rule to 10th. Now barium, I've told you already, barium belongs to group 2. So I'll write 2 plus, instead of writing plus 2, we are just writing it as 2, okay? 2 plus hydrogen. Come on, hydrogen, the oxidation number of hydrogen is plus 1. You know, hydrogen H plus is plus 1. But hydrogen will become minus 1 in metallic hydride. When we talk about metallic hydride, a good example of metallic hydride, good examples are plus 2, okay, because it's a group 2. So we're just going to write 2, okay, it's still the same as plus 2, but there's, for convenience, let's just say 2, okay, it's still the same thing, plus 2 and 2 is the same thing. Plus, hydrogen is usually what? Plus 1, except in metallic hydride, where it is minus 1, okay? Hydrogen is usually plus 1, except in metallic hydride. Now, examples of metallic hydride are, these are examples of metallic hydride. For example, lithium hydride, sodium hydride, potassium hydride, okay? For this are magnesium hydride, calcium hydride. Okay, these are examples of metallic hydride. These are metals. Metallic hydride, metallic hydride, metallic hydride, metallic hydride, metallic hydride. Okay. Now in metallic hydride, just know that the oxidation number of hydrogen will be what? Minus 1. Okay. All right. So this doesn't look, this is not a metallic hydride. So that's the reason why hydrogen, it will be plus 1. Okay. So we're going to say plus 1. We just write it as 1. 1 times 4. Because we have 4 of hydrogen here. Plus P2, I'm going to write it as what? 2P, plus minus 2 times 4 equals to 0. Okay, so this will give us 2 plus 1 times 4 is 4. So plus 2P plus minus 2 times 4, that's what? Minus 8 equals to 0. Now this will give us 2 plus 4 is what? 6 plus 2P. Now plus minus is minus, so minus 8 equals to 0. Now 6 minus 8 is minus 2. Minus 2 plus 2P equals to 0. It's just like taking like terms, okay? 6 minus 6, we go with 8. 6 minus 8, that gives us minus 2 plus 2P equals to 0. Now, minus 2 will cross the sign of equality to this side to become plus 2. So, minus 2 will cross the sign of equality. This is the sign of equality to this side to become what? Plus 2. So that will give us 2P equals to 0 plus 2. So 2P is equals to 0 plus 2 is 2. So we divide both sides by 2. So P becomes what? Plus 1. So this is what we have. Okay. We're dividing by 2 because we want phosphorus. That's what we're looking for. All right. So this is what we have as our answer. So you can see that the oxidation state or the oxidation number of phosphorus in this compound is plus 1. So that is all you need to know regarding the oxidation number calculations. It's Dr. Cliff. Bye for now.